and welcome to our first webinar of our C.A.R.E week, the Climate and Renewable Energy Week for EOS Eco-Energy, made possible by the Environmental Trust Fund of New Brunswick and with the network help of Renewables New Brunswick. And today we're learning about Cape Tormentine Watershed with beautiful presenters Miranda Corkum and Lauren Clark. I'll be monitoring the chat over the period of time that we're having the presentations, and after each one, we'll make sure to have space for important questions and answers. But as mentioned in the chat, we are recording this for later publication and use, and also really want to capture some of the important questions that come up. But if that makes you nervous for privacy reasons or anything else, feel free to turn off the camera if need be, or add things to the chat so I can speak for you if need be, and help with that. So thank you for coming today, and thank you so much for coming to our speakers. I'm very excited and eager to hear about all the watersheds. And I just wanted to first start with a brief land acknowledgement as well before we get started, just to say that we're on the unceded and surrendered territories of the Wabanaki, the people of the Don. So that's the Mi'kmaq, the Wolastoqiyik, the Abenaki, Penobscot, and the Passamaquoddy people under the Peace and Friendship Treaties of 1779. And I find that especially important that our office here is in what it used to be traditionally known as Siksnik, which is the drainage lands. And I think that's incredibly important to know as we speak about the important watershed that we have, because that has been traditionally how this area has been known. But not only that, it is one of the main functions and an incredibly important resource that we have for climate change adaptation and everything in between. So without any delay, I'm just going to make sure that Lauren and Miranda get to introduce themselves. And I'll just start with Lauren, and then we'll go right into the presentation with Miranda. All right, thank you, everyone.
Thanks, Julia. Yeah, I'm Lauren Clark, and I used to be the Energy Projects Coordinator for EOS Eco-Energy, and I also have done the habitat assessments. So I'm excited to present some of my results to you after Miranda's presentation.
So hello, everyone. I'm just going to share my screen. Hopefully everybody can see. A slide with a picture of a beach on it. Everybody's all good. Yeah, okay. So I'm Miranda Corkum, and I'm the EOS Water Quality Project Coordinator. And I just wanted to say welcome and thank you for joining us on your lunch break today. So we're here to talk about the results of the 2022 Water Quality Monitoring Program in the Cape Tormentine Peninsula Watershed. So this work was carried out by myself and Cal Dutta, who is the EOS Watershed Project's summer intern. So although Julia has already done a land acknowledgement, I just wanted to say that EOS would like to respectfully acknowledge that our work is done on the traditional unceded lands and waters of the Mi'kmaq people. Just to begin, what is a watershed? So a watershed is an area of land that drains rainwater or snow into one location, such as a stream, lake, or wetland. Maintaining the quality of surface water is essential for a healthy watershed, and we all rely on healthy watersheds for clean drinking water, food production, industry and manufacturing, and for tourism. So EOS has been monitoring water quality in the Chignecto watershed since 2018, thanks to funding provided by the New Brunswick Environmental Trust. So the province of New Brunswick has 13 major watersheds. The Chignecto watershed area includes the inner Bay of Fundy composite and part of the Northumberland Strait composite. And these areas are circled in red there on the map. So EOS monitors 3 sub-watersheds on alternating years. So that's the Tantramar River area, the Rockport Dorchester area, and the Cape Tormentine Peninsula area. So the Cape Tormentine Peninsula area was last monitored in 2019. It covers 452 square kilometers of land area, and has a total watercourse length of 328 kilometers. It has only one fourth order river, and that's the Gaspereau. All of the water in this sub-watershed ultimately flows into the Northumberland Strait. Land use in the Cape Tormentine Peninsula area includes agriculture and forestry activities, residential and commercial developments, municipal sewage lagoons and private wells, and the Cape Juryman National Wildlife Area. So water quality samples were collected this year from 12 sampling sites that were selected based on accessibility and to represent a mix of brackish, which is sort of saltier, and freshwater sites, as well as more impacted versus less impacted sites. So impacted sites are areas that have been developed, such as like roads, residential or farming properties, cleared fields and pastures, for example, while less impacted sites are more pristine environments with intact forest buffers. So our sites were spread out all over the peninsula, and Lauren will be speaking a little later on in this session about a stream assessment she did of the Trout Brook site last summer. So we monitored water quality here, but she also did a detailed stream assessment. So we'll be learning about that a little later on. In situ water quality parameters were measured in the field from June through September using either a HANA multi-parameter probe or a YSI meter. We measure pH, temperature, conductivity, dissolved oxygen, total dissolved solids, and salinity. In the interest of time for this presentation, I'm just going to present the data for the temperature and dissolved oxygen, but if you have any questions about any of the data, we can always answer those. This photo on this slide is of Cal collecting in situ measurements at the Gaspereau River in Port Elgin. So in addition to these in-field parameters, we also collect bottle data. Samples were collected from June through September, and they're brought to the RPC laboratory in Moncton for analysis of water chemistry, metals, and bacteria. A total of 59 parameters are returned to us from the lab. So for our in situ results, water temperature is the first parameter I would like to discuss. So higher water temperature means that less oxygen can be dissolved in the water, and this has implications for aquatic life, such as fish. The summer of 2022 was generally warm and dry, and water temperatures experienced typical seasonal variation. So June, which is on this plot, the dark blue bars, had lower water temperatures, and the temperatures sort of increased throughout the summer into August and then dropped down again in September. Now, according to the Environment Canada recommended guidelines for the protection of aquatic life, water temperatures of streams should not exceed 20 degrees C. So if you can see on this plot, there's a horizontal red line that shows the 20 degrees C cutoff for temperature. And we can see that in August, so August is the, I should just point out here so it's clear, along the x-axis we have the different monitoring locations. So there's 12 different monitoring locations. And the y-axis here, we have the temperature in degrees Celsius. And the different colored bars represent the different months that were sampled. So the green bars here are the month of August, and you can see they're all over that cutoff line except for one spot, and that's Rayworth Brook. This is similar to what was seen in 2019, except for in August 2019, there were actually only 2 sites that exceeded guideline. In 2019, the warm temperatures came more in July. So these higher temperatures could be attributed to lower water levels, slower moving water, less overhanging riparian vegetation, and also the mixing with the warm waters of the Northumberland Strait at our brackish sites, because the shallow Northumberland Strait boasts some of the warmest waters north of the Carolinas. So new this year, Olton Brook site was chosen for our first temperature logger deployment. This brook is tidally influenced and has a wide grassy floodplain with trees on the upstream side. This picture here. And then it was fairly channelized, and it had some bank undercutting as well. And looking downstream of the sample site, there were vernal pools and salt marsh near the mouth of the brook. And so you can see looking downstream, it empties directly into the Northumberland here. So a temperature data logger is simply a portable measurement instrument that's capable of autonomously recording temperature over a defined period of time. So Olton Brook is a tidally influenced site which sees large swings in temperature on a daily basis due to tidal cycles. And we can see from this plot, if we look at this darker red line here, this is at the 23 degrees Celsius mark. And we can see that at times temperatures exceeded the 23-degree mark for the entire day. And this can be extremely stressful or even lethal for fish. So we have no previous temperature logger data to compare to yet, but it's useful to have this information in our data bank for the future. So dissolved oxygen is another very important parameter that we like to look at. It's the amount of oxygen that's dissolved in water available for aquatic life. As water temperature increases, the dissolved oxygen decreases. So the New Brunswick Water Quality Guideline for the Protection of Aquatic Life is 6.5 milligrams per liter DO. And that's, again, shown with the horizontal red line on my plot here. So this is our cutoff line. So the highest DO levels this year were seen at Rayworth Brook. So that's this site here in the middle. The lowest DO levels were seen at Trout Brook off Murray Road. So that one's over here. So all months sampled had DO levels that were quite far under the recommended limit. If you have a keen eye, you might notice that not all of these sites have 4 bars on this plot. That's because we had a malfunctioning DO sensor in August and September, and we were unable to obtain measurements at 4 sites. So we're hoping to get a new instrument for the next field season. So I just wanted to show, so Rayworth Brook is a site that I've shown had low temperatures and high levels of dissolved oxygen. It's a really pristine site. And you can see it's got lots of overhanging vegetation, so nice shady spots for fish. And I don't know if you can see in this photo, but all the little lines and specks that you kind of see here, these are all fish. It was just chock full of what looked like trout. So yeah, it was a really, really special site. So our bottle sample results. So I think I mentioned that 59 parameters were returned from the lab. Well, I'm only going to focus on just a couple of those. One that's very important to us is total phosphorus. Phosphorus is a component of many important nutrient compounds that are used by plants, and it can be present naturally due to geological formations or decomposing organic matter. However, it can also enter waterways from fertilizer runoff, manure storage, wastewater treatment effluent, and leaching septic systems. So New Brunswick has a total phosphorus guideline for the protection of aquatic life of 0.03 milligrams per liter total phosphorus. So this red line down here is our cutoff for total recommended phosphorus levels. Most of our samples this year exceeded the New Brunswick guideline. And they were in the eutrophic state. So eutrophic state means somewhere between 0.035 and 0.1 milligrams per liter. And we even had 2 sites that were in hypereutrophic state. So that means up above this 0.1 milligram per liter cutoff. So that would be Blacklock Brook, Route 955. And then again, this Trout Brook off Murray Road site. So as a key nutrient that can lead to an increase in algal growth and a decrease in dissolved oxygen in our waterways, phosphorus is a parameter we would like to investigate further. So E. coli E. coli are bacteria that live in the digestive tract of warm-blooded animals, and they're used to indicate the potential presence of harmful organisms. So the presence of these fecal indicators could mean that there are other disease-causing pathogens present, such as bacteria, viruses, or parasites. Health Canada has a single sample maximum guideline for Canadian recreational water quality set to 400 E. coli per 100 mils. So you can see here on this plot, it's a little skewed because of some very high readings, but here's this red line way down here is our 400 mil per liter cutoff. We can see that the guidelines were exceeded 18 times at 9 sites this past summer, and extremely high levels were seen at Trout Brook off Murray Road. So this little break in the graph, I had to do that just to fit the peak on on this page. So it had counts in July up at the 10,000 E. coli per 100 mil range, which was extremely high. So this Trout Brook off Murray Road site, just to give you a bit of background, you know, this is CAL collecting in situ measures in June, and you can see in June it was very very turbid, and it's not a fast moving brook, it's quite slow moving. And just across the road, we saw in September there's actually cattle that were grazing in the brook just upstream of our sample site. So I understand this is the Botsford Community Pasture. So a community pasture, I understand it is lands that are owned by the province and leased back to groups for grazing cattle. So it's not surprising where the cattle are in the water that we saw such high levels of E. coli at that site. As for metals, most came in well below detection limits, which was really great. Some exceptions were aluminum, iron, lead, and zinc. Aluminum and iron levels were elevated at most of our freshwater sites. However, New Brunswick is known to have higher levels of naturally occurring aluminum and iron in soils. So it wasn't really, it's not too surprising. And also, we did see, however, lead at Trout Brook off Murray Road and zinc at Trout Brook Route 955. So those were sort of two parameters that sort of stood out this year. So in conclusion, a successful season of baseline water quality monitoring was completed in the Cape Tormentine Peninsula with results that were comparable to 2019. Some sites showed signs of stress in the form of elevated water temperatures, total phosphorus concentrations, bacterial counts, or decreased levels of dissolved oxygen. And more data is needed to support the freshwater health in this rural watershed. As far as future work for the EOS Water Quality Program goes, we would like to return to the Rockport Dorchester area in the summer of 2023. This was last sampled in 2020, and this would complete a final year of baseline data collection for this area. We'd like to develop an integrated watershed management plan to guide and focus future monitoring and restoration efforts in the Chignecto area. We'd like to continue to engage with community members and landowners to promote watershed best management practices and improve riparian buffer zones. So Lauren's going to talk a bit more about this, but you know, improvements would include greening the shoreline. That would mean like having native plants next to the shorelines to reduce erosion and sedimentation, fencing water courses near farms, maintaining domestic septic tanks, reducing chemical inputs, such as through the use of lawn pesticides and fertilizers, reducing impervious surfaces. An impervious surface would be pavement, for example, and also by picking up after our pets. So there's always room for water quality improvement and more work that could be done. So at this time, I'd like to first acknowledge that this program is supported by all kinds of groups. New Brunswick Environmental Trust Fund, obviously, as well as Experience Mount A, Astor Group Environmental Services this year was extremely important to us. They loaned us their Kona EV, so we were able to get out to the field and get to our sites. The Chignecto Watersheds Committee provides valuable input on where we should be collecting samples and things. Again, the CAL was a super help, our summer student intern, and many other groups that supported us along the way. We thank all of you because we couldn't do it without your support. And if there's any questions, feel free to jump in. That's all I have to say at this time.
Thank you so much, Miranda.
Sure.
Now, were there any questions? Oh, I see there's one. Go ahead, Megan.
Hi, everyone. For your presentation, I wanted to ask if you could speak to cyanobacteria. Did you see any evidence of that? Is that a concern in this area? Is there any testing for that or the toxins that can be produced? I'm looking into sort of what's happening in the province, and I'd be curious to hear what's happening in this corner. Thank you.
Great question. Thanks for asking that. So we didn't see any evidence of cyanobacteria blooms in the areas that we were looking this summer. However, we did not test for them, so we didn't collect samples. And to my knowledge, I don't believe anyone is in this area. So I'll just say that the New Brunswick Department of Health, they're responsible for monitoring E. coli and Enterococcus at Murray Beach Provincial Park and Campground. So that site actually is in between two of our river outputs that we looked at this year, Trout Brook off Route 955 and Scott Brook off Route 955. So they collect a lot of bacteria samples. So the fecal coliforms, they're collected at Murray Beach every 3 days, I believe, sort of like May through September. It's possible, that they might be collecting the odd cyanobacterial sample, but they don't report those results on the provincial website. So I'm not aware of any data that exists. But it is a great question, and it's something, especially with those really warm temperatures, that would be good to keep an eye on.
Thank you.
I just had a quick question, Miranda.
Sure.
At one point you mentioned a fourth order river, and I just wondered if you could explain what that means.
Oh, okay. Well, so I don't have my, there's actually measurements, I believe, that are associated with that scale. It's a scale of rivers. Basically, a fourth order river is fairly big. For example, our Tantramar River in this area is a fourth order river. So I don't know the exact measurements, that define that fourth order, but it's just simply a fairly large river.
Gotcha. And it would have a lot of other smaller rivers flowing into it, I assume.
Streams or brooks. Yeah, exactly.
Right, streams or brooks.
Yes.
Okay, gotcha.
Thanks, Lauren.
Thank you. No worries.
Perfect. And I guess just one more question for me. Since the theme of Climate Change and Renewable Energy Week is around celebrating climate change solutions, did you find any of the data hopeful, or are there any things coming up around our watershed that we should be excited about, or that we can empower ourselves to take care of our watershed a little better?
Well, let's see. I guess it's important to point out that when we go out collecting these samples, I mean, we're just collecting one sample on one day a month. So it's really a very limited, it's very limited in scope, what we can sort of, the predictions and things we can make from this kind of monitoring. But, you know, it's not, the health of this watershed isn't terrible. I just think it's good that we're looking at it and people are aware of some of the areas that there are issues, just so we can keep an eye on things, you know, and just kind of just it just helps us to, okay, well, we saw a lot of sites with E. coli this year, a lot of sites with high phosphorus. It's good just to keep that information in our mind when, you know, when people are building new properties or renovating existing ones, you know, there are things we can do, there are decisions we can make to just help support the environment a little bit. For example, like with the septic systems and stuff like that, which I think, you know, I think moving forward, people are thinking more about those kinds of things. Yeah, but Lauren is going to make a little mention at the end of her talk about things we can do, like right now in the winter, to sort of support the environment and support water quality. So I won't steal her thunder there. I'll let her.
Segue.
Yeah.
Yep.
So Lauren.
And thank you so much, Miranda, yet again.
Oh, of course. Thanks.
All right, I will share my screen. If you want to stop sharing, Miranda. Oh, new slideshow. Is that good? Can everybody see that? Yes.
Can.
Okay, good. I see the thumbs up from Miranda. Thanks. Great. Okay, cool. Well, so this is my intro slide, and I want to give a huge thanks to Cal Detta again for her help this summer. Like Miranda said, she was one of the student interns that worked with EOS. Thanks to Matt Ellison for the internship funding. Thank you to the Petitcodiac Watershed Alliance for letting us use their YSI when our multi-parameter probe was acting up. And of course, a thank you to the New Brunswick Wildlife Trust Fund for funding this project. So for those who are not super familiar with Scott Brook, I've drawn a very crude red circle on this map to sort of show you the general placement of it and where we went. And so Cal and I went out in the field from June 14th until July 20th to this area and did our sampling. So we did 32 assessments in total, so 32 reaches. And I'm going to explain what a reach is in a second. But first, I just want to say, you may notice that the stream assessments are spread out a bit, as in there are some large gaps in the middle. And this is because of the conditions that we encountered in the field. So, for example, I don't know if you can see my cursor, but in this first little area here, it was quite swampy. So, so it took us a really long time to hike out to it and then hike back out of that area. So by the time we sort of got to the 10th reach, we decided to kind of move on to a new section in hopes that it would be a little bit easier to get to. And so that's when we encountered the problem of the back roads, which some sections were very muddy. And although I did have a RAV4, I did get stuck twice, actually, and had to be pulled out. The first time we got pulled out, excuse me, by a very kind farmer who brought his tractor along and pulled me out. And the second time I got pulled out by the principal of Port Elgin School, Christopher Becker. So the difficult field conditions definitely cut down on the amount of time that we had to do to actually do the habitat assessments, which is why there are not quite as many as I might like. And this is a picture of the second time we got stuck. And it turns out I should have just gone straight through the road. I saw the puddle and I was like, ooh, I might get stuck in that. Went off to the side. It was swampy. It's not a good idea. And going back through it after I'd been pulled out, I didn't get stuck at all. So the moral of the story is try and go straight through the road, even if there's a big puddle there. Okay, so I'm just returning to this slide to sort of explain what a reach is. So we did 32 assessments, like I said, and those were broken up into 100-meter increments. And each 100-meter increment is called a reach. So at the beginning of each reach, we would collect in situ data. So things like temperature, pH, dissolved oxygen. And we did that with a multi-parameter probe. And then the habitat assessment data was collected every 25 meters. And that data involves things like, oops, let me see if I can go back. So that involves things like looking at substrate on the bottom of the stream, looking at banks for different levels of erosion, what type of vegetation is there on the banks, what is the vegetation hanging over the stream, how much vegetation is hanging over the stream, taking measurements of the width of the stream, the depth of the water, the height of the banks. And so then we take those values from each part of the reach and we average them. And that lets us analyze and compare the different reaches. So we broke the stream up into 3 different sections. So upstream, midstream, and then downstream. And we were looking at 3 kinds of data. So riparian zone conditions, channel conditions, and aquatic habitat conditions. And I'm going to start with the riparian zone. So the riparian zone conditions were, on average, good. So a riparian zone is the strip of vegetation that grows along either side of a natural water body, like a stream or a brook. So this includes things like bank erosion, bank vegetation, and shade cover. So the majority of the banks that we surveyed were stable for the most part, with a minimal amount of erosion. Average bank conditions, there was a bit more slight erosion than heavy erosion on both sides, which was good. And average vegetation cover for grasses was relatively high, between 48 and 57%. And because of these large amounts of grass, the combined averages of shrub and tree cover were quite low, but below 45%. And then the midstream section had the lowest average shade cover with only 32%. So here are just a couple pictures. This of the grassy vegetation that we saw, and then the banks that were slightly eroded, as you can kind of see. So now I'm going to talk a little bit about channel conditions, which were on average poor. So we found high levels of sand and fines in all 3 sections of the brook, and they made up an average of 74% of the substrate, which wasn't great. Here are a couple pictures. You can see there's really no, rocks or gravel or, bedrock that you can see. It's all very soft, fine bits of sand and clay and mud and things like that. And the last group of data that I analyzed were the aquatic habitat conditions, which are things like temperature, pH, dissolved oxygen, metrics that were captured with the multi-parameter probe. And aquatic habitat conditions in 2 of the stream sections demonstrated average temperatures above 20 degrees Celsius, which, as Miranda already discussed, is not great. And also average dissolved oxygen values in all 3 sections of the stream fell below 9.5 milligrams per liter, which is the minimum amount needed for early aquatic life stages. The minimum amount of dissolved oxygen needed for most forms of life is 6.5 milligrams per liter, and 1 section of stream did not meet that threshold. Average pH values were pretty good. So average surface water, or healthy surface water, sorry, should have a pH that falls between 6.5 and 9. So average conductivity, total dissolved solids, and salinity did not indicate the signs of saltwater intrusion. And lastly, average reach composition ranged from pool to riffle to run, and run was the highest percentage of 88% and above in all 3 sections. So to take a closer look at stream habitat, EOS used a point system to rank each 100-meter assessment to identify potential restoration sites within Scott Brook. So these factors were used to assign points to the site based on the quality of the habitat. And using a point system allows for the identification of healthy habitat or sites in need of restoration. And as you can see, 6 factors were used in the point system to define a potential restoration site. And each factor was allocated a certain number of points, while taking into consideration the impact each factor has on the overall health of the watershed. So 11 would be the highest amount of points that a site or a reach could receive, which would indicate very poor habitat conditions and a site that would be in absolute need of restoration. So the point system is an easy way to identify sites in need of restoration. However, the sites will still need further evaluation to decide which restoration efforts are best suited for the area. So this is a map of the assessments with their respective colors. So you can see at the top, green indicates a healthy reach. So that reach will have between 0 and 3 points on the scale shown in the slide above, excuse me. Orange indicates that the reach is healthy with problems. So it will have gotten between 4 to 6 points. And then red indicates that a reach is unhealthy, so it will have between 7 and 11 points. I've already mentioned the reason for the gaps. There are certain reaches here that are labeled. They don't have any particular significance. It's just a screenshot from Google Maps, and for some reason those reaches were highlighted. I do also want to point out the one white section there. So this was an area that was very hard to access. It was very wide, it was very deep. It was almost like a lake, and I'll explain the reason for that later. But because we were not able to access it very much, like we couldn't measure the width or the depth, you know, we had our probe in there, but really couldn't take a look at the substrate or anything like that. I just decided to not rank that reach just because we weren't really able to collect enough data to be able to use the points system. Okay, so just taking a look at the first section of assessments, you can see the map there. And again, I think it like doesn't label reach 3 and 4, but that's just a screenshot from Google Maps. But we did 10 assessments in total. And this section of Scott Brook was reached after walking 0.8 kilometers up a resource road to reach the beginning of the stream. And of these assessments, 4 had a score of 0, meaning that they were in good condition. And the remaining sites could benefit from potential restoration projects. So the remaining 6 sites ranged in number of total points. 4 were designated as healthy with problems, and the 2 others were designated as healthy. And of the 10 sites, 5 sites recorded vegetation consisting of at least 60% grass, and 4 sites recorded banks that were slightly eroded. In terms of in-situ parameters, 5 sites had dissolved oxygen values below what is required for early stages of aquatic life, and 2 sites had an average pH value below what is suitable for biota. And then midstream. So the midstream section of Scott Brook was accessed after driving 1.5 kilometers down Blair James Road. We were then able to park and walk alongside the brook. So we completed 1.8 kilometers of the brook, which resulted in 18 assessments. And none of those assessments had a score of 0, meaning that 100% of them could benefit from potential restoration projects. Again, like I said, that white section, you know, we weren't able to collect the majority of the data. So because of the large amount of missing data, we didn't give that reach a score. But the remaining 17 sites ranged in total number of points. 6 of the reaches were designated as healthy, 7 were healthy with problems, and then 4 of the reaches were unhealthy. And of those 18 sites, half of them had more than 60% grass as vegetation, and they also had low shade cover. 7 of the reaches recorded banks with high percentages of heavy erosion, and 3 had high amounts of light erosion. Only 2 reaches recorded stream banks that were 25% or more bare of vegetation. And actually all of those reaches had average temperatures over the recommended Environment Canada guidelines for streams. And also dissolved oxygen values below what is required for most signs of life. 5 of those reaches had pH values below what is suitable for biota. And finally, the downstream section. So we accessed this section of stream from where the brook passes under Murray Road. So we parked along the shoulder of the road, went down the embankment, and made our way upstream from that point. We completed 0.4 kilometers of the brook downstream, which gave us 4 assessments. This portion of the stream was tidally influenced, so the water level rose and fell with the tides. So when we started out, the water was, you know, fairly high, and then we noticed that it was getting higher, and then on our way back to where our car was parked, we were like, oh wow, the water's definitely higher now. And we hadn't even thought to check the tides, but that's what was happening. So 2 out of the 4 assessments had a score of 0, which means that the other 2 reaches could benefit from potential restoration projects. 1 of the reaches was designated as healthy and only had 1 point, and the remaining reach was designated as healthy with problems. Only 1 of those sites had more than 60% grass as vegetation. 2 of the reaches had less than 25% shade cover. No significant erosion was present. 2 of the reaches had average temperatures over the recommended Environment Canada guidelines for streams, so over 20 degrees. So some potential restoration measures that could be taken for streams that had, you know, points associated with them. So, you know, tree planting in riparian zones for streams with stream banks that are bare of vegetation or that have large amounts of grassy vegetation. There was certainly quite a lot of that. We came across a blocked culvert, which was the reason for the lake. So that could be cleared out. We did come across some dump sites, so those could be cleaned up. And also the construction of brush mats along silty stream beds could help sort of take that silt up and out of the waterways. So I wanted to include a bit of a public service announcement at the end of my presentation with regards to winter salt use and watersheds. So the Belle Isle Watershed Coalition in New Brunswick has done some monitoring, some measuring, and they have found that salt levels in some New Brunswick watersheds in the winter are similar to that of salt levels in the ocean, 35 parts per thousand. So why is that not so great? Well, salt can alter the soil, can harm plants, weaken infrastructure, and it also gets into our streams, lakes, and rivers, which puts aquatic life and human health at risk. And it only actually takes 1 teaspoon of salt to pollute, as it says there, 5 gallons of water or 19 liters, which is quite a lot. And they have some tips here if you are going to choose to use salt, which I know you know, nobody wants a super icy driveway or icy roads, like that's super dangerous. So there are some ways to help sort of reduce your use of salt, as it outlines there, you know, shovel before the snow turns to ice. Really scatter the salt if you're going to use it. They say a coffee mug of salt is enough to treat an entire 20-foot driveway. And then once it's done its job, you know, try your best to sweep up the extra so you can reuse it. But if you would like to look for alternatives, I have a couple of suggestions. So, you know, a lot of these alternatives to salt will add traction. So like sand and kitty litter, for example. The citric acid in the vinegar is what helps to melt the salt. And then beet juice will actually work in below 0 temperatures, which is often not the case for other de-icers. So some areas have been experimenting with adding juice, the beet juice, to their regular road salt routine, which has been known to reduce the amount of salt needed by 30%. And then we have alfalfa meal, which is commonly used as a fertilizer that some folks have tried using, and coffee grounds. And so that's the end of my presentation. If anybody has any questions.
Thank you so much, Lauren. I don't know if there are any questions, but we'll give people a moment for it. Yeah, did you find that the salinity was noticeable in your Scott Brook activities, or I guess also for Miranda? Is it a big deal? Because I know Atlantic Canadians can't imagine, you know, very icy roads, but I can only imagine it's a huge deal, even though we have really high salinity in a lot of our tidal zones.
Yeah, I didn't notice high levels of salinity. I mean, the level was a bit increased when we were in that tidally influenced area, but certainly not, you know, at alarming levels. I imagine, and I've never done any monitoring in the winter, so, you know, I imagine the levels there would be quite different, but I didn't notice elevated levels, which is interesting. Yeah, I don't know if you have any feedback, Miranda.
Well, as Lauren said, I mean, we weren't out. We weren't out on the peninsula in the winter, but there are some issues with salinity in some of our sample sites, but it derives more from saltwater intrusion. So yes, we have sites where the salt levels are higher than what we would expect, but that's because of high temperatures and low water levels, and just those the Northumberland salty tides pushing in further than they would otherwise. So not exactly from. It's not a function of people over salting their their driveways and things, but still, as Lauren said, like it's something that everybody could do, like right now, just to keep water quality in their minds when they're doing something as simple as salting their steps. So.
Thank you.
Sure.
And there was also something I wasn't sure everyone knew the definition of. What are the brush mats or brush mat construction?
Yeah, so I'm not super familiar with them, to be fair, but it's my understanding that you would put some, you know, vegetation together to make sort of like a mat, and then those would be installed and sort of anchored to the sides of streams, so that they could, you know, collect sediment after a period of time as the water, you know, flows through them. Sort of excess sedimentation could be picked up and removed from the stream. That's my understanding, although I'm not super familiar with them. But yeah, that's kind of what I understand them to be.
Thank you.
And if anybody was curious, I do have a couple other slides just showing, like, I did mention the blocked culvert at one point, and then the lake. So I could just show people, if they were curious, what that looks like. unless there's another question right now.
I'd like to see that, Lauren.
Okay, sure. So this was the culvert that went under the road that we used, and you can see there is some water flowing out of it. And when you're standing directly across from it, you'll notice that there's no light that seems to be coming through the other side, which I thought was quite odd. So I went to take a look. And I don't know how well you can see that, but there is a lot of vegetation in the end of that culvert that is totally blocking, not totally blocking, but blocking a lot of water runoff. And then this is what it looks like on the other side. I only had waders, and the height of the depth of this water is quite deep, and so I wasn't able to get in and sort of investigate what the other side of the culvert looked like, but you can sort of see the width of the stream there, and it's quite wide compared to the rest of it. And so I was sort of confused about that for a while, and I figured it's probably the blocked culvert is sort of made the water kind of pile up behind it. So that's certainly an option for restoration work in the future.
We have a question from the chat just about who's responsible for cleaning out culverts in the area, and where's the location of the blocked culvert?
Yeah, so the blocked culvert is on the Blair James Road just before it turns into Noonan, I believe. And so it's a road that's sometimes tricky to traverse. I never got stuck on that road, at least up until that point, but certainly wouldn't want to go on it in just a regular car. I'm not actually sure whose responsibility it is in terms of culverts. I don't know if anybody else in the chat would know. I know the Petitcodiac Watershed Alliance has some experience with cleaning out culverts. Yeah, I don't know if anybody else would know, but I don't, unfortunately.
I briefly thought Lewis was maybe offering to go and unblock the culvert. Where is it so I can get in there? So Blair James Road. Okay, great.
Just on the topic of culverts, with my time during culvert assessments at the Petitcodiac Watershed Alliance, the Department of Transportation and Infrastructure is supposed to be responsible for it, but since they're low capacity, they go through a prioritization schedule. But this one looks really bad. If it's an outflow drop on the other side, fish can't access the culvert, and that is a big old lake. So I'm not sure, but hopefully it's on their radar, so that doesn't wash out the road. But yeah, really interesting pictures. Thanks, Lauren.
No problem. Thank you for sharing that. If there aren't any other questions, I do have one other point of interest that I could get into, if you like. So, yeah?
Sure, yeah.
Okay. So, while we were doing the habitat assessments, I was taking photos of plants that I found that were interesting, and marks in the ground and that sort of thing. And I uploaded them to iNaturalist afterwards, and it turns out that I discovered a new plant species, sort of, a new plant species for New Brunswick, at least. So the marsh thistle is a plant that hadn't been seen in New Brunswick. I have a picture of it more up close. You can see it kind of looks, to me, it looked very like an alien. I don't know, I just hadn't seen anything like that before. And so I took a picture and put it on my naturalist. And according to Sean Blaney, who I trust, who's knowledgeable about these things, It's a new species for New Brunswick. So that's sort of a side and aside. That was cool. And yeah, just wanted to share that.
Exciting. Well, thank you both so much. I do have like, if anyone wants to answer or ask any questions, we still have 5 more minutes, but I'm sort of curious about how much of the riparian areas are grass. Is that very normal for Tantramar? Is that unique to our area? And yeah, I would love to know what you think is special, what are special characteristics of our watersheds and how we can better steward them.
Yeah, that's a great question. I'm not totally sure, to be honest. I mean, the thing about grass is that it's not as great as like larger vegetation at like anchoring in the bank and sort of preventing erosion as far as I understand. But I do know that, you know, they're changing all the time in terms of their course and that sort of thing.
And I hadn't much considered how much shade would affect that, but assuming that this huge, lovely salt marsh we live on, that grass is usually where all of the shade and the sturdiness comes from a lot of the time. Is that true, Miranda?
Sorry, is what true?
That most of our shade cover and the riparian vegetation tends to be grass in our area.
Well, I guess it depends where you look, but we do have a lot. Yeah, there are a lot of grassy. I mean, we do have a lot of marsh areas. We have a lot of agriculture, so there's an awful lot of fields in our area. We don't have so many like condos on the edges of our rivers and things, but we do have a lot of fields. So yeah, I guess we are a pretty grassy area in general. Lauren, I think that's what she probably would say too. Yeah.
Yeah, for sure. And I feel like maybe, you know, marshes are quite ecologically productive and they're doing quite well. So yeah, so maybe if it's considered to be a marshy area anyway, then it's okay if there's a bunch of grass. Whereas, you know, maybe if you're looking at an area that was more clear cut, that was forested, presence of grass is maybe more alarming. So yeah, I'm not super sure about the intricacies there. But yeah, that's certainly something to keep in mind because yeah, the Tantramar marshes are huge and there's not a lot of trees there. But you know, they seem to be doing okay. So in terms of, you know, I don't know about water quality and that sort of thing, but yeah.
Okay, perfect. Well, thank you both so much for your time, and thank you everyone for joining us. And as long as we have no other questions, I guess if you both would like to sign off with what we should watch out for coming up for watershed restorations or ways we can support your work in the future, that'd be great.
Well, I think there are some plans, some potential plans to do some cleanups that will hopefully be funded. And then as Miranda was saying, I don't know if you want to get into more details, Miranda, but I know you did mention monitoring up the Rockport, Dorchester area next summer. I don't know if that's confirmed, but.
Well, it's always, we wait until those ETF funding announcements come out, but that's our hope. So we can take another good look at that, the peninsula on the other side this summer. Yeah, so that's quite exciting.
Perfect, thank you. And we'll make sure to look for the next Blitz announcements. And thank you so much, very much for your time, and looking forward to hearing about the next steps. Thanks everyone for joining and have a great day.
Thanks, Julia.
Thank you, Julia.
Thank you.